Colorado Television. Experiments in Physics with Dr. Frank Oppenheimer. A brief demonstration of the equipment used in the Library of Experiments in Physics, produced in cooperation with University of Colorado Television. Today's experiment.
In this experiment, one can see the behavior of charges when they force between charges and study Coulomb's law. It's done by having a large copper sphere mounted on a nylon insulating rod and a small light pith ball, which is graphited, also mounted up, suspended from a nylon thread. If this is charged, then one allows the pith ball to touch it. It picks up a charge which is roughly proportional to the area. I say roughly because conditions of contact are not too well known. Then as the force repels this, there's a force mg sine theta pulling down, so that if one knows the angle, that is the length of this suspension and the deflection, one can find out what the force is. And since if one assumes the charge was shared, one can find out how much charge was on each of these spheres. And one can study the way the force varies both with the charge and with the separation of the spheres. The first thing to do is to make sure there is no charge on the sphere, then to see that the balls are centered, and we can check that with the shadow. In fact, we'll use the shadow to measure so that we don't disturb this either with our body, by getting too close to it, or by touching it. The first thing to do is to mark the edge of one of the balls, of this ball, in its equilibrium position when there's no charge, no force on it. One can also measure the diameter of this ball, and from this diameter and this diameter get the scale factor. There's a point source of light over there, and one can either measure the distance from there to the ball and from the light to the blackboard, or just use the ratio of those two diameters to get the scale factor. Then we'll charge this up. The Van de Graaff here is perhaps a little closer. Then it's good to have it in the experiment because it might influence, its field might influence the pith ball, but we'll charge it. Sometimes it takes a few tries to get a good charge. I found it's best to run it for a moment, then let it stop. And let's see if that is a good charge. We can tell by whether we get a good deflection. That's not a very good deflection. One should be able to get a noticeable deflection this far away, so let's try again. It may depend a little on how dry the day is. Let's see if that's better. It's still not very good. I think it's worth trying once more and seeing if we can get a good charge. Let's see what that does. That's a little better. I've seen still better than that. So I'll mount this here. And notice that we get a deflection that's measurable from this distance. If you were doing it, it might be worth trying to get a little bigger charge and getting even more sensitive. I'll mark this and call that the position of the sphere 1. And I'll mark this edge here and call that the position of the ball 1. Might be good to make a little mark like that, and like that right along the line of centers. The distance between them will be from this center to this center, or you can verify that Coulomb's law applies under those conditions. And now if you call this distance, the deflection will of course be this distance. And I can try other positions and mark those. I can go through a whole series of measurements as rapidly as possible. Call that S2. There it is. And there's the ball too. Then to see that charge is not leaking off, I can go back and see if I get reproducibility. And I can come up again. And now I can do other experiments. For example, at this position, I can take an equal size sphere and touch it to that. And presumably under those conditions, half a charge is on each sphere, so I've cut the charge in two. Notice that this has an effect while it's up there. Then I can either remeasure the distance, or I think one perhaps gets somewhat better result if one then brings the ball back to exactly where it was when you had the full charge and remarks this point here. I'll make a little X, because this is now also S2 by just accident. It's S2 for 1/2. So having made all the marks on here, I can then either try and reproduce them or simply make the measurements now. But it's good to make all the marks before you start measurement, because even under the best conditions, the driest conditions, there will be some leakage. Notice that if I get very close to this, I influence its position by my own body. That's why one wants enough space between the fifth ball and the shadow. That, I believe, is all that there is to this experiment. And you can, having calculated a rough value for the value of the charge on that sphere, you can compare the size of that sphere with the Van de Graaff sphere, and in the same way calculate what the potential must have been on the Van de Graaff when you charged up this copper sphere. That's all there is.
Experiments in Physics with Dr. Frank Oppenheimer was produced in cooperation with University of Colorado Television. This is University of